This is a Chevy Volt first gen DC-DC converter. And these are the cables that you need to connect it. Welcome back to our Chevy Volt with a V series. Today we're going to take a deeper dive into the cables, wire harnesses, wire harness-eye, wires, cables, thingamajigs, metal tubes that it takes to wire the DC-DC converter. Now we're going to start off by me showing you how it was connected when it lived in the OEM vehicle. We've learned in a prior video that the DC-DC converter lives in the trunk of the car. Okay, now we're going to go through these cables one by one, and I'm going to explain to you, as far as I know from what I've seen, how they connected and what they do. So we're going to start with the longest one, right? Because it's right there in our face. And the reason I wanted to demonstrate this to you is because when looking for cables on eBay, this may answer the question why we may not find this particular one, okay? It is encased in this metal tube. It does have a connection here on one end. I believe this side goes to the trunk. And on this side, unfortunately, this one has been cut already, but to us that doesn't matter. For an EV conversion, we would cut off one end anyway. The guys that I purchased this from told me that yes, this was already cut, I think when they pulled the battery out or the engine or something like that. That's okay. Point is, it's like 57 feet encased in this shaped aluminum tube. And the eBayers that sell it may ask you, a lot of money to ship it because they assume you're going to use this in an OEM application and they don't want to rebend it or what have you, damage it. So then it has to go in an oversized package. That's at least what I assume. I was lucky. I scored a lot of these cables for like $100 at a local wrecker. It really helps to visit your local wreckers and just establish a relationship with them. I'm not an expert by any means, but I will chat them up and say, hey, I'm converting this type of car or this type of truck. And a lot of them are really into it. Honest truth is they don't know that much about hybrid vehicles, plug-in hybrids, electrics. This is not a knock on these technicians, on these businessmen and women. There's just so much to learn, right? A lot of them won't even touch electric cars, but as they get into it, they're learning and discovering what these things are. So sometimes they will call a box by like 3 different names: inverter, converter, controller, what have you, charger. And so you see all these mislabeled eBay auctions. Anyway, this is our first cable. If you imagine that my table here, this gray table, is a Chevy Volt that's parked in front of you, this will be the rear of the car, and on this end is the front of the car, okay? So in the back of a Volt, we would find the converter sitting like so. And this cable would run the length of the car underneath the vehicle and connect it in the front there to the battery pack. There is actually an intermediate cable here, okay? This intermediate connects the inverter inside the trunk. So this pops in here like so. And I will post some pictures of how these plugs, these orange high voltage plugs are keyed because they are not interchangeable. They are not interchangeable between the converter and the charger, and they're not interchangeable between the first gen converter and the second gen converter. So this is how it's sat in the back of the vehicle. All right. You may get away with just getting this intermediate cable. That may be enough for you to just cut it off and make it go to your battery, because this is the input to our DC-DC converter. The high voltage 360 volts will come in through this. Now we'll strip this off. We don't need the metal. We'll just need the wires inside of it. I'm just demonstrating to you what it looks like. So it will come into the battery. So high voltage comes in. This is the high voltage input. And then there is this wire harness, okay? It was taped together. It's really two wires. There's a little shorty here. Let's see if I can do this and not make a complete fool out of myself. So this little shorty is just the ground. Okay, it goes on like so. And that is just the ground to the chassis in the trunk. And then this one here is the battery positive. It will run from this plastic encased post terminal, and it runs to the battery. Okay? Whew, I'm winded from carrying that heavy thing. Let's just pretend that's a regular car battery. This happens to be a deep cycle battery. But yes, electric cars, hybrid cars still use a 12-volt car battery. I know you are sick and tired of me saying that. So I just brought it out here to show you as a demonstration that positive output from the converter goes to the positive of the battery. Negative just goes to the ground. Now, let me zoom in on this so you get a better look. Okay, so now that we have our high voltage input and low voltage output, there's one more crucial connection on here, and that's what I call communication. Right over here, there's a sort of RJ45 looking connector. We're going to use a piece of a main body harness. You cannot purchase this by itself. It doesn't have a part number on it, okay? You can buy the connector and the pinout and the pins and make it yourself. Or you can just ask the junkyard to cut you a pigtail. Cut it as long as you can. I'll show you a picture of how this runs from the converter to behind the seat. It disappears behind the seat. Okay, the width of the car across the vault. So I know how all of you love watching me thin out wiring harnesses. So we have one here that I'm going to unwrap on camera, take one for the team, get my hands dirty. And I think it's important to get the right pigtails and take your time and unravel these black harnesses to see what really lives in them. On an EV conversion, there are chances that if there's 10 wires in here, we may only need 5. So why run them all? Just cut them out and simplify the implementation. Now for this, I have these plastic clips. So I'm just going to use some, I think these are called die cuts or something. Dikes. Cutter thingies. So we'll cut these off. And if you guys want to play a fun drinking game while I do this, drink every time I take my glasses off and put them on, because I recently became, I guess, nearsighted, and the glasses that I had, the proper glasses with the transitional lenses or whatever, just broke on me. So I went to my old pair, and now I have to do the grandpa thing and take them off and actually see what I'm doing and then put them back on. So this looks like the really nice German Volkswagen, Mercedes, BMW, Audi, whatever, cloth tape. I really like this tape, but I like putting it on, not so much taking it off. So it looks like we have the black cloth tape and then kind of the typical conduit, corrugated stuff. Okay, it looks like right here we have taped in some sort of a bracket. So we'll take that off. And since I'm not highly skilled technician, I enjoy this kind of work because this is like my speed, right? Ooh, we're taking tape off of harness. Yep, we are. This is my idea of reverse engineering. Man, how the heck? So we're going to use a box cutter here. And make sure it's sharp. I've heard the saying, there's nothing more dangerous than a dull knife, which I call bullshit on that. And the funny thing is that there is something more dangerous than a dull knife. It's a freaking sharp knife. I actually observed my uncle, my wife's uncle, who's a chef, literally just proclaimed that in our kitchen one day, saying, you know, there's nothing more dangerous than a dull knife. And he sliced his hand with a really sharp knife, one that he just himself sharpened in our own kitchen. That was an interesting moment. I think we had blood spaghetti that night. So yeah, this takes time. It is a pain in the ass, but it minimizes the risk of cutting through the wires, right? So I think there is a disadvantage to asking for the longest pigtail you can get. You got just that much more crap to unwind. cutting the tape here. Okay, so here we go. So this is interesting. Right away, what we can see. Okay, so I brought you guys in closer because I want to show you something. You can tell that there are 4 wires, okay? And 4 wires here. And 2 are loose, but 1 seems to be intertwined. It's what we call a twisted pair. When you see something like this may be a giveaway that this device, whatever you took this off of, is CAN enabled. It communicates via CAN bus or CAN, okay? Not always, I wouldn't say this is 100% proof, but it's a hint, okay, that these here wires are for CAN, and these here could be for, one can be for something called CAN high signal, and the other one can be for something called CAN low. Now, it kind of looks like there might be more wires coming out of this connector running to this black tape and then only 4 coming out. So I'm going to undo this and see what happens there. My glasses, so you make sure to take a drink. How the heck? Oh. See if we can maybe cut it gently. All right, so here's something very interesting, all right? Like I told you, there's more wires coming out of the plug than there actually are continuing on. I hope you can see that here. There's a white wire that loops back on itself, and there is a, what is that? Bluish with the black stripe, and it loops back on itself. So very interesting. I don't know what those are yet. We'll have to learn, figure it out. Okay, and then we have let me bring this guy in here. So there's that, there's a connection. Obviously it plugs in like this. And what we're going to do is we're going to try to identify these wires next, what they are. But the ones that loop back are pretty interesting. Maybe if you know why they're like that, go ahead and put something in the comments, really appreciate it. One thing with my videos, and I'm going to be brutally honest, I am not an expert. Not as if any of you were fooled into thinking that to begin with. But if I know something, I'll share it. If I don't, I plainly state that I don't know it. So let me go get a pinout cheat sheet, and then we'll go over these connectors. So I've got the pinout for this connector. This is compliments of Mr. Arbor Kramer. I don't know how to pronounce that. But he's been actually active on my thread for the DC-DC converter. 1,000 thanks. super. I really appreciate that. He has a blog called Leaf Drive Blog. I'll post the links in the comments or in the description for you. Unfortunately, I don't have enough views or subscribers or followers to put direct links in my YouTube videos. Thank you so much, YouTube, for getting rid of that feature. Really helpful. Okay, so we just have a list here of pins 1 through 10. And what's on them. I still don't know kind of where the numbering system starts, but we're going to assume it starts in like the natural upper left-hand corner, I guess. And so number 1, it says terminator resistor. So if we go 1, 2, 3, 4, 5, 6, 7, 8, and that's interesting. Are they numbered? Oh, I see, they are numbered. Okay, so this looped thingy, that is actually number 1 right here. And right away we see that there are 10 pins or ports, if you will, pinholes, but we only have eventually 4 wires coming out, call it 8 to begin with. So there are 2 empties. Looks like 4 and 9 are just empty, and that confirms Arbor's pinout here. So pin number 1 has a terminating resistor wire, I guess, and then 2 is can low. So the white wire of our twisted pair is can low, making the blue and black one can high on pin 3. Then we move on to pin 4, which is nothing. Then we move on to pin 5. This is pin 5 here. This would be the upper right corner for you guys. This is ignition. And then we continue on, and pin 6 is terminator resistor. Then pin 7, can low, which is interesting because that's where this goes. It says same as pin 2. Then pin 8, can high, same as pin 3. Pin 9 is nothing. And pin 10 is accessory. All right, so this is interesting because I did not see anything called a ground in there. Let me get more documentation and be right back. Okay, so now that we have the pinout figured out, now we need to look at the instructions on what wires go where. So we start off by supplying power to any type of device that we start off with. Okay, so we need to connect on this one pin number 5, which is enable pin, which is called ignition, and pin number 10, which is accessory to 12 volt. So if we look at this, and actually we can easily grab 5 and 10. They are the last 2 wires here. I'll try to post pictures of close-ups. And I am going to go. All right. So we have ourselves a pretend car battery here, and we will take these 2 wires and we're going to pretend make them go to the positive of the battery. Then it goes on to say the negative pole of the 12 volt battery has to go to the ground of the connector of the DC-DC output. So that would be here. Okay, so we're just kind of building up on our knowledge here. Now there's no harm in just connecting this ground because the positive isn't connected. So we're just going to go ahead and connect it here. And look foolish doing it, but we'll figure this out. Okay, hopefully that won't pop off. So at this point we've got what I would call permanent 12 volts. So that's pin 10 from the battery positive to this connector, pin 10. We have another wire, which is the ignition, which is the enable. That will be when we turn the key on. Then it would send 12 volts. So that is on pin 5. That is going from the battery positive to the box. And we have our third wire, which is going from the battery negative to the DC-DC low voltage output post here, okay? So that's kind of the power of it. And then we're left with this twisted pair gizmo here. And we have can high, which is pin 3. Let me peek here. So that would be the blue, I think. And can low, which is pin 2, which is the white. And those will go to whatever our CAN brain will end up being, or our CAN bus analyzer perhaps. I am getting a bit ahead of myself now. I'm going to save that for a later video. So yeah, I think this is as far as I want to take the hardware portion of this presentation. And we will do a follow-up video where we actually deal with the software. Now the software is kind of going to fall into two categories, so I don't want you guys to get confused. I will start off by doing a little bit of troubleshooting and like pretend reverse engineering. By no means am I smart enough to reverse engineer this. I'm just copying what has been done by, you know, Arbor Kramer, Damien McGuire. I don't know if Tom Debris had his hands in this, probably did, and other brilliant guys. I'm not even following in their footsteps. I'm just kind of walking along the side of their footsteps, pretending I know what I'm doing. Anyway, so I'm going to bring out 3 different CAN bus analyzers, like a $40 one, $80 one, and like a $160 one. And so, you know, cheap, medium, and then pricier. And we may even bust out with SavvyCAN from EVTV and Colin. But the reason I didn't want to jump into SavvyCAN is because it relies on Arduino, and then we just pile on a lot of complexity. So the 3 other solutions are kind of off-the-shelf commercial CAN bus analyzers. One thing I learned about CAN bus analyzers and learning about CAN is that whoever you ask, they're using a different little gizmo than the one you've seen last time. Everybody uses something else, okay? So if I show you something, pick what you like, use it, don't use it, doesn't matter. There are so many different things out there. I was driving myself crazy saying, which ones do I want to review? Which ones do I want to learn? I don't think there is a free solution to CAN bus analyzing, because you need a hardware. You need a piece of hardware to tap in to the CAN high and CAN low signals. I believe those little gizmos are called transceivers. We can get something called an Arduino. Arduino makes different entry levels, from entry level, mid level to higher level circuit boards with microcontrollers on them. There's something called a Nano and an Uno and a Dewey. I don't want to talk bad about the lower level, the Nano and the Uno, but they're kind of toys. Yes, they're powerful and you can make a ton of projects with them, but for car use, if you're jumping into Arduino, jump in on the Dewey level, okay? You pay a little bit more, and it may be like $20, $30, and $40 price points. Jump in at the $40 price point. again, getting a bit ahead of myself, but we want to go ahead and save that for a later video. This was going to be just about the wiring and connections of this box, and we'll do a follow-up video and we'll bust out the CAN bus analyzers. And then the other side of that is the actual controllers, right? So EVTV makes a little box, a brain, a controller for this. Damian McGuire put out some code on GitHub for the charger, not the DC-DC converter, for the charger, the sister product of this, that I'm hoping to look at and maybe pick up something from that to use to control the DC-DC converter. And then there is also Tom DeBree's SimpBMS. Unfortunately, that's a really expensive product. I love supporting all the open source efforts, so I will be getting SimpBMS. I think it's like $600 in United States to get one. I've only seen few people selling it here. And then I want to get, the display for it and some other gizmos, so I have the whole suite. So I might be looking at like $900 for BMS, which is battery management system. But one of the flavors of SimpBMS is for my battery pack, which is BMW 530e. It's what they call the hybrid, BMW hybrid battery pack. So there is a hybrid BMS, SimpBMS, and it manages the Chevy Volt charger, and I think it also can manage and control the first gen DC-DC converter. So look for another video. I'm learning along with you guys. This is fun stuff. It's cool to learn this stuff. It's cool to figure it out. And even if we don't go with this solution, if we use a Tesla or a Nissan Leaf, there are some fundamentals and basics that span all the ecosystems. If you know CAN, you know CAN. No one can take that away from you. And you can learn how to control other devices. And if you don't reverse engineer it yourself, at least you know what went into it and how it works. And if your vehicle unfortunately breaks down or has a problem, you'll understand how to troubleshoot and fix it. That's about it for this video. Thank you so much for watching.